Hello, everyone. Welcome back to the main stage. I hope you enjoyed your break, and thank you for joining us back here. Just a quick reminder that starting now in track 3 is AI-powered asset development, revolutionizing the life cycle. A masterclass is led by PwC. So if you're interested in that, please do head there. Here on the main stage, we have a bit of a treat for you because up next we have the one and only Dr. Roman Yampolskiy. He's an author, associate professor of computer science and engineering at the University of Louisville. He is the founding and current director of the Cybersecurity Lab, and also an author of many books. His latest, and the one he's going to be talking about now, is called AI, Unexplainable, Unpredictable, and Uncontrollable. Please welcome Dr. Roman Yampolskiy.
Thank you so much, all 10 of you, for showing up to my talk. It's very hard to compete with refreshments. I understand that. So in the next 15 minutes, I'll tell you about maybe a decade of my work. In case I run out of time, you can learn more by following me on social media. You can follow me on Twitter. You can follow me on Facebook. Please do not follow me home. It's very important. So, just under 2 years ago, a new AI product has been released. I'm sure all of you seen it, played with it, heard of it. It's called GPT. What was completely different about this AI is that for the first time, it was not a narrow product, not a system just capable of playing chess or driving a car, but it was something with sparks of generality, artificial general intelligence. It could take exams at the college level in law, in medicine, chemistry, physics, and it did better than many students, and definitely better than average people. It was a complete game changer. And since it was the first time scientists actually thought we have something general, immediately debate has started about, well, how long until artificial general intelligence in a true sense, a system capable of doing anything any person can do in any domain. If you look at predictions made by CEOs of top AI labs, Anthropic, DeepMind, OpenAI, they are saying we are maybe 2-3 years away from AGI. Of course, they have some financial interest in suggesting that they are close to such a breakthrough product. So we can also look at prediction markets. Prediction markets where people bet real money on their knowledge, on predicting future. And while it's a market and it fluctuates, you can check what it is today. The last time I looked, it was saying the same thing, 2-3 years until AGI. That's not a long amount of time. And we're starting to see a lot of people, famous people, rich people, influential people, express concerns about this technology. Will we be able to control it? Can we guarantee that it's going to be safe? And it's not just famous people. Thousands of top computer scientists have signed a letter stating that they think this technology, this advanced form of intelligence, alien intelligence, could be as dangerous as nuclear weapons in terms of existential danger it presents to humanity. Turing Award winners, Nobel Prize winners, a lot of founding fathers of machine learning all signed this letter showing levels of concern we haven't seen before for any tool, for any software. They are suggesting that this is not just a tool, but it's an agent capable of competing with us, a different species, an alien species, if you will. So that presents a problem for us. How do we control such advanced intelligence? That's the AI control problem. And typically in computer science, before we start investing resources into a problem, we try to understand, well, is the problem even solvable? Is it solvable with resources we have? Maybe it's partially solvable. Maybe it's impossible to solve. There is not a consensus when it comes to the state of the AI control problem in computer science. If you look at what experts in the field are saying, and I took a kind of diverse sampling of leading researcher in machine learning, godfather of machine learning, Turing Award winner, Nobel Prize winner, an AI safety outsider, and a director at the time of a top superintelligence alignment lab. And their opinions are as diverse as they can be. They range from, well, obviously it's solvable, to, I have no idea. This is not a good state of affairs. So in my research, I try to understand what can be done to solve this problem. If you think about it, it's like creating a toolbox of capabilities we need to control an advanced agent. We should be able to explain how it works, comprehend that explanation. We should be able to predict what it's going to do, verify the code and the goals of a system, and probably many other important capabilities. Maybe one or two of them are not available to us, but we can always possibly use a different tool for the same job. So this is what we try to investigate. Which of those tools are available to us and to what degree? For each one of those capabilities, we have published a peer-reviewed paper, journal, conference paper, all showing that there are upper limits to what is capable in terms of control, in terms of understanding, in terms of predicting advanced agents. And we're not just limited to AGI. Very quickly, if we get general intelligence, those systems help us with science, with engineering, with research, and with development of more capable AI. So almost immediately, we're likely to see superintelligence, systems not just capable of doing what every human can do, but to outcompete everyone in every domain, including research and AI, leading to this intelligence explosion of capabilities. So if we are talking about such advanced agents, what can we say about our ability to understand them? The only true explanation for a large neural network is the model itself. Billions of neurons, many billions of connections between them. That's the only true explanation for how a decision is made. You cannot survey it. You cannot comprehend that explanation. So what we can do instead is get a simplified explanation. Top 5 reasons why your bank loan got denied. That's useful, but it's not a true picture. It's like lossy compression. You're losing information in a process. So you can see there are limits to what we can understand about workings of those large models. Likewise, there are limits to predictability. You cannot perfectly predict specific actions of a smarter agent. Let's say you're playing chess against the best piece of software in the world. You can accurately predict that that software will win against you. It's going to win the game. But you cannot predict specific actions that system will take. If you could, you would be playing at that level. You would be the world champion. So obviously, that's not the case. There are also limits to verifying software, verifying large neural models, verifying mathematical proofs. We know how to do it for mission-critical systems, for software for controlling nuclear power reactors, airplanes, short, static pieces of code where we know what the edge cases are, where we know what the outputs should be. There is no capability to verify dynamically changing code, code which continues to learn, interact with users, learn from new data, and even self-improve, rewriting itself. Any proof, any verification is with respect to a specific verifier. It could be a scientist, could be a group of scientists. More and more, it is now a piece of software, a verifier. But of course, someone else has to verify that piece of software. So you have this infinite regress of verifiers. So there are limits to what we can prove as absolutely correct. And if you put more resources into it, you can obtain more guarantees, but you never get to 100%. And if your system makes 1 billion decisions a minute, and you only make one mistake every billion decisions, after a few minutes, you're not in good shape. In case you like such impossibility results, I do, there is a paper we published in the top ACM journal which surveys about 50 such impossibility results, such tools. There is really more that we cannot do than we know how to do in this space. And those are not just limits in computer science. Many are in mathematics, economics, political science, even physics. There are strict upper limits on all those capabilities, all those tools we need to solve the AI control problem. So we published a paper looking at different types of control and showing that, yeah, in fact, there are limits to that control as well. I don't have time to go over all possible definitions of control, but the two extremes are direct control, where you give orders to the system. That's known as a genie problem. You get 3 wishes. Usually your second wish is to undo your first wish because you screwed up pretty bad. The other alternative is to go, okay, this system is very smart, smarter than me. It knows me better than I know myself. I'll just trust that system to tell me what to do. It's my ideal advisor. Maybe you'll be happy with it, but you're definitely not in control. And so we published those results. The paper was well received. We published similar results in the Time magazine. I collected all those papers and results in a recent book, again, well received, written for non-scientists. Anyone with basic understanding of technology can understand. And we don't limit ourselves to just impossibility results. We also talk about who is responsible, ownership of AI, internal states of those systems. But this is kind of me telling you what I discovered. What is the state of the art? What does the community think? Then I do surveys, informal surveys in audiences such as this. Almost no one thinks we can indefinitely control superintelligent agents. Then I survey nerds who follow me on social media, on Facebook, on Twitter. Those are not large samples, not scientifically valid tests. Only about 1/3 of AI experts think the problem of control is actually solvable. What are they all concerned about? They are worried about existential risks, problems these systems can cause in terms of developing other weapons, chemical weapons, biological weapons, or simply getting out of human control. This is known as probability of doom, or PDoom for short. And you can see a list of top scholars, people who really developed this technology, who historically invented most of it or currently developing it. And those numbers are large. If they were around 1%, that would be too high for all of humanity to be bet on success of this technology. But the average is about 30%. And many think those numbers are much higher, 40, 50, 60, even close to 100%. That's not sustainable. That's not something we should be operating under. So what is the concern we have? We are not just creating a new model and making sure GPT-5 is going to be safe and secure. We are trying to create a perpetual safety device, a system which, after learning, after self-improvement, after interacting with new users, with hackers, with new data sets, will continue to be safe as it goes transformation from one model to another. GPT-7, GPT-20, it never makes a single mistake. Because if you make a mistake in standard cybersecurity, it's not a big deal, really. We issue new passwords, we give out new credit cards, everyone goes home happy. But if you mess up with superintelligence safety, a system which is capable of causing existential catastrophes, you only get one chance to get it right. So, by analogy with perpetual motion machine, which we know is impossible to create, there is a good reason to think it's impossible to create perpetually safe superintelligence systems. So that's my presentation, and I'm very happy to answer any easy questions you have about it. Thank you.
Roman, I thought that was really, really interesting, but you failed to tell us when you think AGI is coming. Do you believe that we're going to have general artificial intelligence in the next 3 or 4 years? It seems insane to be contemplating that sort of timescale.
I think we have it right now. I think the systems we have today are already smarter than average human in every domain. It speaks hundreds of languages, can program in any language. Google at this time uses AI to generate 25% of all source code written. Any type of task, tutoring, anything, first thing I do is I go to AI. I don't go to a human expert. I ask AI first, because it's usually better. It can learn new skills, and it's getting better at all those tasks we talked about. So it's becoming harder and harder to find something where humans are still dominating. Humans, again, average humans, we have this tendency of always go, well, Einstein can do it better. Forget about Einstein. Look at average person and how they compete with those systems. Intelligence is defined as ability to win in multiple domains. Not just a single domain, but across many domains. If you score how those systems do on thousands of tasks, they're better than you right now.
Your questions, please. One here. I want to get to as many from the audience as I can. Yes, sir.
Professor?
Yes?
Professor, I'm a fan of yours. Just a question. Would we see a day when we have empathetic code written? Can we have a kill switch incorporated into the AI? Because AI is intelligent. Can it decide, well, do I pull the trigger or do I not pull the trigger? So if I pull the trigger, the consequences are there. So, because we're mimicking a human being. So would there be any chance of an empathetic AI?
So two questions I think you're asking. One is about kill switch, and there is a lot of research on doing it, and basically the answer is no. The system is smarter than you. It knows you're about to shut it off. It will kind of do the first strike. It will make sure you have no capability to turn it off. It is distributed. It has backup systems. It is not going to happen. As far as being empathetic, altruistic, you can try to instill those pro-human values, but you have no guarantee that as the system self-improves, it will not remove those. A lot of times when we create a new AI, first thing we do, we train it on human data. We saw it with Go, game of Go. The next generation is zero knowledge. It ignores human data sets and learns from first principles. From first principles, there is no reason to have a pro-human bias. We try to remove all bias from AI. You don't want to be racist, sexist. Same goes for being pro-human. If you are looking at it from external point of view, it's unlikely to be kept. There is not a rational reason to treat you unfairly, to privilege you above all else.
That is an insane thing to be discussing on a stage in a real world. The idea that we're talking about the development of models that can train themselves based on no data and don't prioritize the creators of that technology in the loop. Like, do you, when you read about it, I mean, I saw some of the papers you had going back, 4 years, 10 years, 15 years. When Gen AI hit the scene, was that a big moment for you in terms of realizing that we were moving at a little bit quicker pace than maybe you had thought?
Actually, it matches perfectly predictions made by people like Ray Kurzweil.
Right.
He mapped computational capability versus what is required to simulate a single human brain all of humanity. And his prediction over a decade ago was 2023, exactly the year GPT-4 came out. Likewise, we now have scalability hypothesis, which is very good at predicting what the next level of models will give us. So again, it is still a miracle to see it happen, but all of it was exactly as anticipated.
Thank you. I'm finding this very surreal. Let's go to another question on the floor.
Hello. Hi, Roman. Thank you for the interesting lecture. I myself work a lot in AI ethics and fairness as well within my corp. So my question to you is, when we reach true AGI, which specific mechanisms do you reckon should be in place to ensure that we still align with the human values?
So the problem with human value alignment is that we don't have common human values. No one has written them down. We don't agree on anything. Any election we see is 50-50 split on every issue. And if by some magic we all agreed on something, or all 8 billion of us, then our values are not static. What we wanted 200 years ago is not the same as what we want today. They keep changing. And even if we manage to fix them, we still don't know how to code it up, because all the interesting parts of human values, what is good, what is love, what is valuable, are not translatable into C++ or whatever language you are trying to encode it in. So I think that's part of impossibility results we discuss.
Okay, do we have time for one more quick question? Okay. I want you to remember the moment you were here hearing that, because honestly, I know people talk about it, but when you read stuff on the internet, there's so many different voices competing there, but the idea that we're really contemplating this sort of a future not so far away, it makes me think about climate change and how globally we all know objectively what the problem is, and yet we haven't come to any consensus of what to do about it. And even those who agree, yes, this we absolutely have to do, we haven't done it. What does that say to you about how we're going to get a handle on controlling AGI in the future? Quickly, please.
Right. So with climate change, they tell us we have 100 years before there is a 2-degree difference. Most people kind of go, it's not a big deal. This technology is almost here right now. If we get it right, it will help us solve all the other existential problems, climate change included. But if we get it wrong, we don't have to worry about climate change at all.
Wow. Ladies and gentlemen, Dr. Roman Yampolskiy, thank you.